Okay, you're back. 16. The top speed of a dragster is 330. All right, now calculate 330 miles per hour into minutes per second. Okay, so that'll be, so you know the acceleration, 5g. Oh, okay, so there we go. But in meters per second squares. And you know the initial speed, the initial velocity is 0 meters, and you computed the final velocity above. So how long did it take to reach this top speed? This is a great question. I love this. I love this question because those of you that are new to this stuff, you're doing some real physics here. All right, this is a real physics question. This is something. Okay, so if I know the acceleration, I want to figure out, hey, is my clock right? Is the time based on what I know about the engine? Actually, 99 times out of 100, we use the time and then calculate these other things. But this time we're going a little bit backwards. So on 16, you know how to do 16. So let's just take a look at it here real quick. So on problem 16, oh, wow. Oh, here's where all my pins are. So on problem 16, 330 miles per hour. You know, that's really, really fast. That's half the speed of sound. So that's, for something on the ground, that's pretty quick. I know we've got vehicles that have actually surpassed the sound barrier, right? You know, our nice little conversion factor. I hate to tell you that every time, but there it is. Okay, so then on 17, we know this. We got V final, which we got from up here. All right, V initial is equal to 0. The 5Gs you got from, I can't remember which, from question 15. Was question 15. So you understand what that is. All right, so here's what you're doing with problem 17. You're doing the acceleration, which is this guy, is equal to V final minus V initial over the time. So we're trying to figure out what the time is. Do you know how to solve that? It looks scary as hell, doesn't it? But it's a piece of cake. Let's do some good old 8th grade algebra here that you hated. Some of you hated. Some of you thought, oh, this is a piece of cake. First of all, I know that V0 is equal to 0. So let's just rewrite it so it's not so scary. Now it's pretty easy. Now it's pretty easy. Multiply both sides by t. So these t's cancel, go to 1. And so the final velocity is equal to the acceleration times the time. And so the final velocity divided by the acceleration that you got is equal to the time. That's the way you'd solve that. If we were taking an in-class test, I might require you to do something like that, but we're not. Piece of cake. You're great. You can do it. All right. Rampage, that's straight from the thing. Let's do some engineering math. Over a 4-second time period. So I think, I don't know if that's the answer that you're going to get up here for 17, but it's pretty close. Let's say she has a mass of 40 kilograms. What is her impulse? Okay, so we didn't quite get to impulse yet. That's in the next slides, but I'll show you what it is. I'll show you what it is. This is gonna be a teaser for what we're gonna do next, because we're gonna find out her impulse is her force times the time, which is delta t. Okay, so you found out her 5Gs of acceleration. I should have said acceleration. If she's only a meager 40 kilograms, ma times delta times 4, 19. All right, and we'll learn about the impulse in the next section. So I'm just kind of setting you up here for failure. No, for the impulse. So problem 19, it's not that it looks scary. F delta t is equal to the impulse. Some textbooks use J. Well, you know the force is mass times acceleration. So the acceleration, again, is 5Gs, but you got to convert to meters per second squared. So make sure you convert. Okay? Make sure you convert that. All right. 20. Okay, theoretically. All right, so now, in the answer above, okay, yes, this is true. All right, so on problem 20, here's what we're talking about. I'm sorry, I had to think about what I was teaching. So in our answer above, here's what we're getting ready. We're getting ready to start momentum, which is my favorite stuff. I just love momentum. We're getting ready to do the force times the delta t is equal to the mass times the change in velocity. In other words, the change in velocity is v final minus v initial, right? Where we know v initial is equal to 0. All right, so you found this in problem 19, and let's call it I. In problem 19, you found this, and we call it I, is equal to m times delta v. Now you take I and divide by 40, and that should be v final minus v initial, where v initial is equal to 0, so that goes away, and that should be your final speed. Just trying to get you to start putting some of these pieces together. And instead of just putting in the answer, just go, okay, go ahead and write it out so you get used to writing it. That's part of learning physics too, is you actually got to get your muscle coordination just used to writing all these equations sometimes. What else we got? Okay, now what's our velocity? Ooh, 21. So here's the last question. What's our velocity in miles per hour? Okay, if we go from the answer in 20, v final is in meters per second. To go from miles per hour to meters per second, we multiply it by 0.447. So if we're going to go backwards in multiplication, what do? Right, you divide. So take her meters per second answer, divide by 0.447, and see what happens. That'll give you the answer in miles per hour. All right, done here. My job is done.